As you go through these, some of these may ask for magnitude, some of these may ask for direction, some of these may ask for both, okay? When they're asking for magnitude, which is like they do on this one, that's when you are going to use your Pythagorean theorem. So our magnitude for all of these, magnitude is going to be based on your Pythagorean theorem. So it's going to be the square root of your x coordinate when you break this down into x and y coordinates and your y coordinate, all right? And so you will be doing, it's always going to be positive and positive. In fact, if you want to write it so that you remember in your calculator, you can actually completely ignore your positives and negatives when you plug these in. All right, so when you plug in your x and y, you do not need to worry about positives and negatives for your magnitude, because the positive and negatives are really just going to tell you which quadrant you're in. Your magnitude is always going to be an absolute value type magnitude, all right? Because we are going to separately tell the direction using angles, okay? So magnitude is going to be that. And then direction. So if they ask for direction, which they did in this particular one, then your direction is going to be used with your inverse tangent. It is always going to be the y value of your resultant over the x value. Now keep in mind, this will give you a reference angle on the coordinate plane. All right, so you do have to think about where you are on the coordinate plane, how they gave you the directions, and how you would in turn give the directions back to them. You want to give the directions to them in the way they gave you the directions. If they said north of east, your direction should give me two different directions, one of the other, right? So if they said a bearing of, that is due north going clockwise, you should give your answer to me in a bearing, all right? For this particular problem, it says a commercial airline is flying with a velocity of 500 kilometers due east, kilometers per hour. They've actually given me the velocity. The pilot receives information that there's a crosswind blowing from the north at 100 kilometers per hour. What is the resultant velocity of the aircraft in terms of magnitude and direction? All right. So anytime they give me due east, due west, north, and south, I do not have to worry about cosine and sine. They have given me a direct information. All right. Due east means I am going horizontal in the positive direction, and I'm not going up and down. Think about what that means on your north, south, east, west. If I have something like this, due east is going to, we're always starting at the origin when we think about these. It's staying right on that line. I am not going up or down, and I'm going on that line 500 kilometers an hour. So that means my x and y for this is just going to be a positive x of 500, and I didn't move y at all. So you don't even have to use your trig functions when they give you a north, a south, an east, and a west, right? That's only when they give you an angular movement on one of those. Let's look at the next piece of this. The next piece says that we have a wind blowing from the north. When it is blowing from a direction, it is actually going the actual opposite direction of the way that it is blowing from. Meaning, if I have this little coordinate plane here, and I am starting at the origin, and I am blowing from the north, that means my wind is blowing due south. From the north means it's coming this direction, right? If it were coming from the south, it would be going this direction, straight up, right? If it were coming from the east or from the west, same thing would happen. So in this case, my movement, again, does not require trig functions. I am actually staying on that axis. I am not moving horizontally at all. My wind is strictly moving straight down, which is south, which means I am just moving down 100. So I am going to indicate that with a negative 100. So for this problem, I did not have to use trig functions up until this point so far, because they gave me direct on my axis movement. Now, the resultant is going to add those. So my resultant x and y is going to be 500 plus 0 and 0 plus negative 100. From here, I am going to get everything that I need to get, all right? So magnitude, Well, we're going to do exactly what I said for magnitude. We are going to plug that in. In your calculators, you can do your square root. It's going to open a parentheses. You can say 500 squared plus 100 squared. Remember, ignore your positives and negatives for these calculations. We have 3 significant digits in this problem. Does everybody see where those decimals were? 3 significant digits here. So when you round this to 3 significant digits, you should get approximately 510 with a decimal, because that looks like 2 significant digits without that decimal, kilometers per hour. Direction. For direction, we are going to use our inverse tangent because we are looking for an angle. So I am, again, going to ignore my positives and negatives because it will try to put you in Cartesian plane if you use your positives and negatives, and it's going to be more confusing. So when you do your inverse tangent, also ignore your negatives, and you're going to say my y value divided by my x value. When you do this, you will get to 1 decimal place, because that's what we're doing, 11.3 degrees. What quadrant am I in? This is when positive and negatives come into play. Go back to your resultant vector. I have a positive x and a negative y. Positive x and negative y means I am in the 4th quadrant. It gave me the reference angle in that quadrant. So it told me I'm at 11 degrees right here. Reference angle, closest to that, down. So now I need to give them directions. How do I give those directions? Well, I would say I am 11.3 degrees south of east. If it was a bearing, I would say 90 plus 11.3 degrees, 101.3 degree bearing. All right? So it just depends on how they gave it to you. All right, so let's look at number 4. It says a reconnaissance aircraft is flying at 600 kilometers per hour on a heading of 120 degrees. This is a true bearing. When they say heading, you're talking about from north clockwise. All right? It encounters a crosswind of 150 kilometers per hour blowing 210 degrees. Calculate the ground speed and actual track of the aircraft. They are asking for magnitude and direction here. All right, magnitude and direction. If they want the track, you've got to tell the magnitude, how fast they're going, and the angle measure in a bearing form. All right, so in this case, we are going to have to use trig to find our x's and y's. We're going to take this one piece at a time. We're going to start with the aircraft. It is going 600 kilometers per hour at a heading of 120 degrees. To figure out your reference angle that you're going to use, you are perfectly welcome to sketch these. Heading of 120 means that I'm starting at north and I'm going clockwise. That's 90. That's another 100 all the way to 120, which means that's another 30 degrees. I am going to use 30 degrees there for this guy. To find my XY value then of him, my X value is going to be my magnitude, 600, times the cosine of that 30 degrees. And then 600 times the sine of that 30 degrees. That will be my XY. All right? So go ahead and solve for your XY. We are going to round to about 1 decimal place in the process, just so that we don't get too far off in our rounding. When we get to the end, we're going to worry about significant digits. Okay? So in the process, go to about 1/10, 1 decimal place. And then at the end, we'll worry about those 3 significant digits. Quadrant matters. So in the quadrant that I fell in with this bearing, my X value is positive. Whatever you get for a Y value, you're going to have to make negative there because I am in that 4th quadrant. Positive X, negative Y. It will affect my final movement. So I do have to worry about X's and Y's with positives and negatives when I'm putting my X's and Y's down. I do need to worry about positives and negatives here. So the next one is a crosswind of 150 kilometers per hour blowing at 210 degrees. So when I'm looking at this one, Again, you can sketch it if you want to. 210 degrees, again, is going to be a bearing. So it is going to be 90, 180. We're actually going to use my 270. So I am going to be how far away from 270? Yes, 60 degrees. So the reference angle that I'm going to use here is going to be that 60 degrees, closest x-axis. So then when I'm doing this one, I'm going to end up in the third quadrant. I am going to use 150, my magnitude, times the cosine of a 60-degree angle. And then 150 degrees, or not degrees, sorry, 150 magnitude times the sine of a 60-degree angle. X and Y are going to be negative here because I am in the third quadrant with this angle. So when I find my X and Y, they are both going to be negative here because I am in third quadrant. I am in third quadrant. I need to find my resultant. That's simple. You find your resultant by adding. So you're going to add your x values to find your resultant vector here, x value. You're going to add your y values to find your resultant vector, y value. So you may want to sketch to remind yourself where you are. Positive x, negative y. What quadrant do you end up in with this guy? You end up in this quadrant right here. Technically fourth quadrant, right? We're going to find magnitude. Remember, you find magnitude using your square root of your x squared plus your y squared. Ignore your negatives in your calculations. Ignore your negatives here. So my magnitude is just going to be the square root of the sum of the squares. At this point, you can worry about your significant digits. How many significant digits do these have? I placed those decimals specifically so that you could see your significant digits. What are they? 3 significant digits. So you are going to round to 3 significant digits. In this case, you should get 618. Your magnitude was in kilometers per hour. Kilometers per hour. All right. Direction. This direction's a little bit different because last time they just said north and east and I could say north of east, whatever. This one gave me a bearing. So I'm going to over to the side calculate my direction using my inverse tangent, ignoring my positives and negatives, y over my x. And I'm going to calculate that, all right? When I calculate it though, it's going to give me a referencing. All right, so when you do this, you're going to get 44 degrees, right? Somewhere in there. That is my reference angle. I need to go back and say, how would I classify that as a bearing? Well, a bearing would start up here at north and then go all the way to that. So I have to consider this 90 degrees along with the 44 that they gave me, right? So to give it to in a bearing form, my direction then is going to go at a bearing of 134 degrees. It's going to be a bearing of 134 degrees. So remember, you started true north and you go clockwise. It gave me, when you put it into your calculator, it gave you this little wedge right here. It gave you this piece. That's all it gave you. You have to consider the fact that we started at true north. True north had 90 degrees and then that 44 degrees. So a true north bearing is 134 degrees. 90 plus the 44. All right, number 7 says Sarah is pushing a heavy box across a rough floor. She applies a force of 150 newtons at an angle of 30 degrees to the horizontal. Her friend Alex is helped by pushing with a force of 100 newtons at an angle 45 degrees to the horizontal in the same direction. All right, so we can assume that our horizontal is our positive x-axis. When they say to the horizontal, If they say above the horizontal or to the horizontal, that just means in that first quadrant. Sometimes they'll say below the horizontal. That just means fourth quadrant. So I just want you to see the wording of how they could say this, okay? What's nice about the horizontal is 9 times out of 10, they've given you a reference angle, right? Because horizontal, they've already said we're on the x-axis. You just have to pay attention. Are we above the horizontal or below it? And then they've given me my reference angle, right? The only time that that would not work out is if for some reason they said something to the horizontal, but they wanted the final in a bearing. So then at the end, maybe you'd have to. But when they give it to you like this, we're going to hand it right back to them with a horizontal measurement, all right? So 150 newtons is my magnitude. Newtons we haven't gotten to yet, but it's just a measure of force. So we're going to look at the first one, 150 newtons, 30 degrees to the horizontal. My x and y for this is going to be my magnitude times the cosine of my direction. My y value is 150 times the sine of my direction. These are both in the first quadrant. So what's nice about that is whatever you get, it's the positive of because I am in my first quadrant. Friend, we're going to look at his magnitude and angle. We're going to do the same thing. He is also to the horizontal in the same direction. So he's not pulling against her. We don't have to assume a negative pull. Same direction, which means we're going to say 100 times the cosine of that 45 degrees and 100 times the sine of that 45 degrees. Again, first quadrant. We're going to say that they are doing exactly the same first quadrant. And then we are going to add. So again, you're going to add your x's, you're going to add your y's. Your x value, and then your y value. All right. All they're asking for here is magnitude. So if all they're asking for is magnitude, you just have to calculate that piece of it. Again, in your calculators, you can do the square root. You can put it all together as long as you show me that x and y. That's what I need to see. So the force on this, how many significant digits are going on with all of these? 3. So we should say force of approximately 248 newtons.